So let's get started on our journey to building a 32-bit floating point adder and subtractor. Now we're going to take care of some of the basic mathematics in this video. I am assuming that you do know how to add and subtract positive and negative numbers. Now just in case you're a bit sticky with that, I have added an extra video into the appendix section, so if you're unsure about some basics, then you can go and have a look at that video before you start the course. So we'll start off with the line up here. Now we're going to be adding numbers together. The first question is, how many numbers are we going to add? Well, that's simple. We're going to add two numbers. We'll call one number x and the other number y. So that's us got off to a good and a nice easy start. Now the number x can be a positive x and it can be a negative x. So in order to write the positive and negative numbers, I've put them in a bracket. So within this bracket, this number is a positive x, and within the bracket this is a negative x. And of course we've got a positive y and a negative y. We've also got two functions that we want to perform. We want to perform addition, which is given by this sign here, and the subtraction, which is given by this sign here. Now you'll notice straight away that the sign for the addition is the same sign that we use for a positive number, and the sign for subtraction is the same sign that we use for a negative number. We don't need to use different signs. Now we're also interested in whether the value for x is greater than y, or whether the value for x is less than y, and whether the value for x is equal to y, but we'll cover x is equal to y later on in the course. We're also interested in the absolute value. So the absolute value of a number is written down as this term here. So it's x with the two lines, and the absolute value for y again is written with y with the two lines. So for example, if you had the number -5 and we were to find the absolute value of -5, that would give us the number 5. So in all cases here, it will just give us the positive value. Now, we're also interested in a couple of properties of the number system. The first is that addition is commutative. That is, if you were to add x plus y, that's the same as y plus x. So for example, 5 plus 7 is 12, and 7 plus 5 is 12. Now, in order for us to do subtraction, we're going to note that whenever we subtract one number from another, it's equivalent to adding on its negation. So for example, x minus y, well that's the same as writing x plus the negative of y. So these are the only properties that we're really interested in terms of our mathematics. Now when we add or subtract two numbers, we're going to have an answer, and that answer is going to have a magnitude, for example 7 or 5, and it's also going to have a sign. It's going to be either positive or negative. So we want to split our working here into these two sections. First of all, we want to look and find the magnitude of the answer, and secondly we want to find the sign of the answer. So we want to have a look at all of the possible combinations of adding and subtracting positive and negative numbers. So we know that the x can have a positive or a negative value. So that's two values for the x. We know that the y can have a positive and negative values. So that's two values for the y. So it means that we can draw out a little truth table. So let's say, for example, we want to add the values of x and y. Now Sx just stands for the sign of x and Sy stands for the sign of y. So let's say we want to add together two positive numbers. We could also add together a negative and a positive, or we could add together a positive and negative, or we could add together a negative and a negative. Now whenever we add together two positive numbers, we get a positive number. So really what we're saying here is we perform an addition. Now the best way to look at this is via examples. So let's say we take the number 7 and the number 5. we could add 7 onto 5, and you'll note here I've put plus 7 in the brackets, which tells us it's a positive number, plus 5 in the brackets, which tells us it's a positive number, and this is the addition sign here. So when we add these together, we're going to get a value of 12. So the final answer here, that is the magnitude of this answer, is a value of 12. We're just going through an addition algorithm. Now if we look at the bottom one here, if we had minus 7 plus minus 5, then that's going to give us a value of minus 12. So you can see here that the magnitude of this answer is the same as the magnitude of that answer. So that is that whenever we have added together two negative numbers, we perform the addition algorithm. But if you were to look at these other examples here, if Sx or Sy was positive and the other one was negative, then for example we could have minus 7 plus the value of our plus 5. So that's minus 7 plus 5, which is minus 2. So what we've actually done here is we've gone through a subtraction algorithm. We've really said 7 minus 5, which gave us the value of 2, and then the sign is computed separately and we've got a negative value for the sign. So if these signs are different, then we perform a subtraction algorithm. But if the signs are the same, we perform an addition algorithm. Now we could have another 4 possibilities here. We could have again the Sx and the Sy, but instead of performing an addition, we could perform a subtraction. And we could look at the examples here. So let's say for example we had two positive numbers and we subtracted them, then it would just be a case of 7 minus 5. 7 minus 5 is a value of 2. So we just perform that subtraction algorithm. Now again, if both the numbers were negative and we were to subtract, then we would have minus 7 minus 5, which that's equivalent to minus 7 plus 5. Minus 7 plus 5 is a value of minus 2. So again, we've gone through a subtraction algorithm. We've had the 7 and the 5 and we got a value of 2. Now these two here will provide an addition algorithm. So for example, this one here, we could have minus 7 minus plus 5, and that's equivalent to minus 7 minus 5, which is minus 12. So again, we've gone through an addition algorithm to get the value of 12. So that's 8 possible combinations. Now we actually have another 8 combinations, and those 8 combinations are given if we were to swap the value of our Sx and Sy. So you'll notice here in all of the examples we've got our Sx as the larger value. By larger I mean a larger magnitude. So all of the 7s are down here and all of the 5s are down here. But we could swap it round the other way round about. We could take all of the 5s over here and take all of the 7s over there. So that would give us another 8 combinations. So in effect we would have 16 possible combinations that we have to take care of. And we have to have an algorithm that ensures that whenever we work through all of these 16 possible combinations, one, we get the right magnitude or the right absolute value for the answer. And 2, we have to make sure we get the right sign for the answer. And the rest of this video is in how to generate such an algorithm. So you'll notice that this here is actually the truth table for an exclusive OR. Now in our 32-bit floating point arithmetic, we know that the first bit tells us the sign of the number. So if the first bit is a 0, the sign is positive, and if the first bit is a 1, then the sign is negative. So in effect we could replace the positives here with a 0, and we could replace the negatives with a 1. So this table here could actually be written as the 0, 0 giving us a 0, or the 1, 0 giving us a value of 1, or the 0, 1 giving a value of 1, or the 1, 1 giving a value of 0. So this here is an exclusive OR. Now this table here is an exclusive NOR. So this is going to give us a way or a method of working out whether we have to add or subtract the numbers, depending on the sign of the x value and the sign of the y value, and whether we're actually adding or subtracting. But we don't need to use both of these, we can actually use just one of them. And the reason why we can use just one is because of this little section here which we talked about at the beginning. If we were to subtract a number, it's the same as adding on the negative. So rather than working with this subtraction table here, which is an exclusive NOR, we can just convert this back into the exclusive OR. So for example, if I was to take, say, just this line here, then we would have a positive and a negative, and we would be subtracting them. So an example of that would be plus 7 minus 5. Now we've said here that whenever we subtract a number, it's the same as adding on its negative. So we could change this value here from subtraction to addition, and we could find a negation of this minus 5, which is plus 5. So it means that this line here is in effect the same as a positive number and a positive number being added together, which is in effect the top line here. So it means that this line here, the third one down in the exclusive OR, would be the same as the top one for the exclusive OR. And the rest of these lines here match up with these lines here as well. You can just work your way through them. So it means that we only really need one truth table here, and that is the exclusive OR, and we can do the subtraction by adding on the negative value. So we've looked at the 8 possible combinations of adding and subtracting two positive and negative numbers. And we've seen that the subtraction of a number is the same as adding on the negative, and that allowed us to take the exclusive NOR table here, and we could implement this here within the exclusive OR. Now we also mentioned that we're going to have to take care of the possibility that Sx is not greater than Sy, but Sx is less than Sy. So if we were to take this 5 column here and put it down here, and we take the 7 column and put it down here, we would have another 8 possible combinations. But again, those 8 combinations, they are going to drop into just 4 combinations, because we know that whenever we add two numbers together, addition is commutative, so x plus y would be the same as y plus x. So whenever we swap these round about, it shouldn't change, it shouldn't affect the final outcome. So it means that the 16 possible combinations that we've got could be catered for with this simple exclusive OR. So we've got a partial answer to the first question. How do we work out the magnitude of the answer? Well, we work out the magnitude of the answer by either adding or subtracting, and we know that we can use this exclusive OR table to tell us whether we add or subtract for all 16 possible combinations. So if we were to say the Sx here and Sy are going to be exclusive OR'd, then the answer would be Sz. So this Sz here is going to tell us whether we have to add or subtract. And we know it's going to work for all 16 possible combinations, because we can use the fact that in order to subtract, it's the same as adding the negation. And we also know that when we add the numbers together, it doesn't matter in which order we take them. X plus y would be the same as y plus x. So it means that we would only have this simple exclusive OR in order to work out whether we add or subtract. So now we're going to look at the second part of the problem. That is, how do we find the sign of the answer? Well, let's say for example we had our values x and y, and let's say x is greater than y. then we would have, say for example, plus 7 plus minus 5, and that would give us a value of plus 2. Now if we were to swap these round about, then we would have plus 5 plus minus 7, and that would give us a value of minus 2. So the order in which these appear would matter. Now what we're going to have to do is we're going to use the sign of x. So let's have a little look at the previous page. And you can see here that in order to get the correct answer here, that is the correct sign, you'll see here if we were to look at the sign of the answer here is positive, the sign of x is positive. The sign of the answer is negative, the sign of x is negative. The sign of the answer is positive, and positive, negative, and negative. And the same thing for this table here. The sign for the answer is positive, positive, negative, negative, positive, positive, negative, negative. So we can find the answer just by the sign of the answer just from the sign of x. Now this is going to work for us whenever the value of our x is greater than the value of our y. But it won't necessarily work for us whenever the value of x is less than the value of y. Sometimes it will work, sometimes it won't. So let's start putting together our basic algorithm. We know that in 32-bit floating point arithmetic, the first bit will tell us the sign of the result. So if it's a 0, it'll be a positive value. If it's a 1, it'll be a negative value. So we want a little mathematical algorithm that will allow us to go from the 0 and 1 here to the actual decimal, positive and negative. And you can see how we're going to do that here. We know that the negative is given by a value of plus 1. So if we were to write minus 1 to the value of 1, well, anything raised to the value of 1 is just itself. So minus 1 to the power of 1 is just minus 1. So that would be our negative. Now a positive would be given by a value of 0. If we were to write minus 1 to the power of 0, then anything to the power of 0 is just a value of 1. So this in effect would now be our plus 1, so this would be a positive. So it means that if we were to write minus 1 to the power of either 0 or 1, then we would get the actual decimal value, which would be plus 1 and minus 1. So this is just a little mathematical trick we use in order to go from our binary to our decimal for our positive and negative numbers. So if we were to take our value for x and we were to split the value of x into the sign for x and the magnitude for x, then we would have the sign for x here would be minus 1 to the power of the sx, and y would be minus 1 to the power of the sign of y. And we would have the mantissa for x, we would have the radix raised to the power ex, mantissa for y, and the radix raised to the power of ey. So this is just our floating point number. So we can say that the modulus of x is just this part of the number. So it's really the number without the sign, and the modulus of y is just this part of the number. So the algorithm that we looked at before, it told us that if we were to take our value for x and we had to work out whether we had to add or subtract, well, we work out whether we add or subtract the x and y by determining the value SZ. Now SZ again is just the exclusive OR over SX and SY, but of course we have to write it in this format here, minus 1 raised to that power. So this here will give us the magnitude of the result, so really it will tell us whether we have to add or subtract the numbers. And this part out here will give us the sign of the result. So this here is our little algorithm we want to work through in order to get the correct values for all our 16 possible combinations of adding and subtracting positive and negative numbers, and also swapping the magnitudes round so the x is greater than or less than y. So this is us written the algorithm out here that we're going to use. Now at the bottom here you'll see there's a little circle, and this little circle stands for rounding. So we're assuming we're going to add or subtract the x and y, and after we've done that we'll round the final result. But what we're going to do is we're going to go through the 16 possible combinations, and we're going to see there's actually going to be 4 of them that don't quite work for us. So we're going to have to change this just slightly, and we'll do that on the last page of this video. So on this page I've got 8 possibilities of adding our 7 and our 5, and we've got another 8 possibilities on the next page. Now I'm not going to sit and read through every one of them. You can just pause this and have a look at them yourself, but let's just pick out one in particular. So let's say we pick out just at random this one here. We could have the value, let's say it's like 3 and 4, we could have minus x plus minus y. Okay, so in order to work through our algorithm, what we're going to have is we're going to have minus 1 to the sine of x. Well, the sine of x here is going to be negative. So a negative value is going to have a value of 1. So that's minus 1 to the power of 1. And then we've got our brackets here. And in our brackets, we've got the magnitude of x. So that's just plus x. And we've got the magnitude of y. So that's just our plus y. Now, in order to find out whether we add or subtract, we've got to multiply this thing here by our minus 1 to the power of z. Okay, so you can see here we're going to have minus 1 to the power of z. Well, what is z in this instance? Well, z is going to be the exclusive OR here. So we're going to have a value of 1 for the x, a value for 1 for the y, because they're negatives. And whenever we exclusive OR them, we get a value of 0. So it means then in this instance here, we're going to have minus 1 to the power of 0. So this is the little algorithm we have to work through. And if we actually put the values in, you'll see we'll get the right result. We put in minus 7 becomes plus 7. Minus 5 becomes plus 5. The minus 1 to the power of 0, when the power of 0 is just 1. So that's just plus 1. So it means that we're adding these two together. And we're going to multiply them by minus 1 to the power of 1. Anything to the power of 1 is itself, which is just minus 1. So we're going to have minus 1, and we're going to have 7 plus 5. So 7 plus 5 is 12, and we have the minus sign here will give us our minus 12. So I suggest you work through 2 or 3 of these yourself and convince yourself that the algorithm does actually work. And I've rewritten the algorithm down the bottom here. Now, the thing about this is there's actually going to be 2 of them here that don't work. So this little algorithm won't work for these 2 in pink. And you can see here that the algorithm doesn't work whenever the addition or subtraction actually gives you a negative number. So in this instance here, you can see that within the square brackets, we've got a positive, we've got a positive here, we've got a positive here, and a positive here, and they all work. As long as what's inside the brackets is positive, we know the sign is going to be given by the sign of the value of x. But if we end up with a negative here, then we can see here that whenever we work through the example here, we're not going to get the correct answer. So we're going to have to note that in this instance here, the correct answer is a positive, but the sign of x is actually negative. So it doesn't actually work for this instance, and it doesn't work for this instance here as well. So here are the other 8 possibilities, and I've marked off the 2 in pink that don't work. So for example, the answer here is going to be a negative value, but the sign of x is going to be positive. So it just doesn't work for this one. And again, it doesn't work for this one either. So it won't work whenever the subtraction or addition is given as a negative number within this square bracket here. So we're going to have to cater for that. And let's see how we're going to do that on the next page. So this is the final algorithm here. You'll notice that I've added a truth table. The value inside the square brackets here tells us the absolute value of the result. So it really tells us whether we're going to add or subtract the 2 numbers. The value outside the bracket here tells us the final sign of the result. So like we said, we've split this into 2 problems, finding the absolute value and finding the sign. Now in this truth table here we've got the sign of x, which can be positive or negative. We've also got the sign of the value inside the bracket. So the value inside the bracket I've called MR. So the value inside the bracket can be either positive or it can be negative. So there's 4 possibilities here. If the value inside the bracket is positive, then we know that the sign is just going to be given by the sign of x. But if the value inside the bracket is negative, it means that the sign is going to be given by the negation of this sign of x. So for example, if we had a minus 1 inside the bracket here, and we had a 0 here, then it would mean that we would have a minus times a positive, which would give us a minus, which would be the negation of this. So that would be, rather than a 0, it would be a 1. In this case here, if it was a 1, it would be a 0. So this is the final algorithm we're going to use in order to generate our adder and subtractor. So that's us worked out a mathematical algorithm for adding and subtracting our two numbers. Thank you for listening. I'll get you on the next video. Goodbye.